guys. Okay, so we're gonna start with the test review on acids and bases. I went ahead and this time I typed them up, and I'm gonna go through each one so you guys could see it better than my handwriting. So this is for the first one. Now, most of these questions are gonna be in the test. I believe they're like 17 or 18 questions. So not all of them are going to be there, but they work very well with all the questions that are in there. Okay, but basically, if you have this test review, you should get a really good grade on this. Okay, okay. So according to the traditional definition, an acid contains well, basically they're compounds, and they contain basically they produce hydrogen ions, H3O in water. That would be just a quick definition. They are compounds that produce hydrogen ions in water. Acids they basically taste sour, and that would be the second one. The third one is acids react with metals to make hydrogen gas. Number four, base bases they taste bitter. And then number five, bases feel slippery. And number six, acids make litmus paper turn red. So even on blue, it will, in blue, it will turn red, and even if it's a red litmus paper, it will stay red. Okay. So what is neutralization? Neutralization is a chemical reaction. This is between an acid and a base. So I don't know if you guys remember the titration. You were adding a base to the acid, and at the end created a pink color that produced a salt and water. Number eight, these are strong bases. Strong bases are strong electrolytes, and strong acids are also strong. So anything strong is strong. An example of strong acids are such as stomach acids with a pH of 1. That's a very strong. Since if you guys remember, it goes, the pH goes from 0 to 7 to 14. And these are your acids. These are the strong ones. These are the weak ones. This is neutral. And this is weak. And these are strong. Okay. Now again, these are your bases. These are your acids. Okay. Okay, so on this one, so as it goes closer to 7, it's weak. Strong as it goes more to 0, it's more center, it's more weak. And as it goes closer to 14, it's strong. Okay, so weak acids are also weak electrolytes. Weak bases are also weak electrolytes. Okay, an example of a strong base, and I should have put it here, but it's basically a drain cleaner. So it has also like a pH of 13. So you see how it's close to 14. So these are your strong bases. And another one will be bleach. It has a pH of 12.6. So that's a strong base as well. Okay. Okay, number 13. Number 13, an example of strong acids. I actually said that earlier. It's stomach acids would be definitely 1. If you guys see this, it's right next to 0. It would be stomach acids, or even battery. Battery acid is a strong one as well. It's around 1, which correctly describes a solution with a pH of 9 and its POH. Okay, so on this one, since it's a pH of 9, we know that should be a base because you see how it's after 7. So these are your bases. So that is the base. But what would it be? What would the POH be? Okay, so that's your pH. And usually we use this. This itself is the pH scale. This right here, this whole thing, it's called pH scale. Oops, scale. Okay. So basically, all you have to do to get the pOH is actually subtract it. Uh, which is a typo here. So let me go ahead and take that out. It's actually 14. You have to use the biggest number, 14, and then you subtract it with the pH 9, which is equal 5. So that's your pOH. You just get the difference. Okay. And then for number 15, a solution at 25 degrees Celsius with a pH of 7 contains, when here, when it's neutral, it's when, and hydrogen ions, remember that these are your acids and the bases are your hydroxide ions. These are these are your bases. Okay, so when it's neutral, it has equal amounts of acids, which is the hydrogen ions, and equal amounts of OH ions. So it's equal. Okay, that's all it means. So right here will be equal amount. Okay, and that's why it's neutral. Okay, number 16, which pH value indicates the most basic solution? Um, Really, it varies. If it would be the most basic, that means strong. I would say like around 12 to 14 or even 11 to 14. It really, really depends. 14 is the strongest though. So you're going to be given options and some of them are going to be very weak or it's going to be, the lesser the lesser the closer it gets to 7 or even less than 7, that will be the least basic. The most basic are always going to be closer to 14. Okay, so it's going to be one of them. Number 17, so a student records the following observations about an unknown solution. It has a pH of 6, and it turns blue litmus paper red. So just by saying it's a red, then that's an acid. But you see how it has a pH 6, so it's a very weak acid. So it's still close to 7, so it has to be slightly acid. So that slightly means weak acid. Okay, so let's go to the next one, number 18. Number 18, when placed in a solution with a pH of 9, so if it's a pH of 9, that means it should be a base and it should turn blue for base, B for B, right? I mean, it's not the same for acid, but something that you can connect with. It will be a pH 9, it's always going to turn blue, the litmus paper. Or even if it's blue, it stays blue. Okay. Number 19, an aqua solution turns litmus red, so that makes it an acid. The pH of the solution could be from around 1 to 6 or 0 to 6 because it's an acid. Okay. Now let's go to the next page, number 20. Well, at least on my paper, it's the next page. So what is the pH of a solution that results from the complete neutralization of a hydrochloric acid with potassium hydroxide? So what is a pH? It's going to be 7. Okay, neutralization will be pH of 7. Okay, um, which pH numbers indicates the highest level of acidity? Uh, I mean, this is just an example, but it would be around 0 to 1. An example would be battery acid or stomach acid. Those are good ones. What is the purpose of doing a titration? Well, the titration lab mainly is to neutralize the solutions, and then we calculate the molarity of the unknown solution. Now I know we calculated the liters, but in reality it would be the concentration, how concentrated it is. We usually try to figure out how concentrated it is. Okay, number 23, at the endpoint of a titration, What color would the solution be? It would be pink. Um, that at the end point, the OH and the H plus ions are equal. Okay, so that and salt and water have been produced. So that's very, very important. Okay, number 24. Okay, so this was a calculation. I really don't know the answer, but we're going to go ahead and solve it right here. So it will be 2.5 molarity of sodium hydroxide. So just by saying hydroxide, that's a base, the OH. And then how many milliliters of this base, because of this base, and this would be molarity, so of the base, because that's concentration, and milliliters will be the volume. That will be your B, and I'll put a B for base. To neutralize 20 milliliters, so obviously we need the acid side, so it's a volume acid, and this is a molarity acid. Okay, so now we're going to go ahead and the M base is 2.5. So all I'm doing is plugging it in, and then you multiply it by, now we don't know the V base, so that's the one we're trying to solve, so we're going to have to isolate it. That equals to the M acid, which would be 2.0, and then times the volume would be 20 milliliters. Okay, and then we need to isolate this, so they're multiplying, so we need to do division. 2.5, you do the same thing to the other side, 2.5, you cancel this once you move it to the other side, and then you're ready to calculate. The V, the volume of the base, equals whatever you solve here. So that's the one we're trying to solve. So that's why it's very important that you isolate this one. So we calculated, you could multiply the top, 2.0 times 20 equals 40, divided by 2.5 equals 16. So 40 divided by 16 equals 2.5. So it will be 2.5, and that's the volume. So we're looking at milliliters. We're not going to go ahead and change this one to liters. Okay. Okay, the next one. Indicators change color at the end point of a titration. The end point. So as explained here. And then what are the units of concentration? That's molarity. That's your M's. And what are the units of volume? And it's liters officially, but your burettes, your equipment when you're doing titrations are in milliliters. So you always have to convert them if you want it by liters. Okay, the next one, what is the pH range for an acid? It's around pH 1 through 6.99. And what is the pH range for base? 7.1 to 14, around there. And the pH range for neutral, exactly 7. And then now this is another calculation, but except now, instead of volume, we're going to go ahead and solve for molarity. But you basically do the same thing since you're multiplying on both sides. So again, what is the molarity of, and then it's HCl. So that means this is an acid. And then what is the molarity of HCl? So that means they're looking for the molarity of the acid. So this is the one that you need to isolate. Okay, if it takes 10.0 milliliters of NaOH. So this is a base. So yeah, be careful. So this is an MB, and this is the volume. That will be the volume of the base. So that's the volume of the base, not the acid. So be careful. You have to read it. It's of this. Okay, and then it says to neutralize. This is the volume of the acid, and that's your molarity. I'm sorry, the volume of the base, and this is the molarity of the base. And this will be your volume of the acid. Okay, so we're ready. So M base would be 2.5 molarity times the V base would be 10.0 milliliters equals the M acid. That's the one we don't know. So I'm just gonna put an Ma times the V acid is 15.0 milliliters. So we need to isolate the Ma. So we need to move that 15 to the other side. Since there's multiplying, you do the opposite. You divide. Then you do the same thing to the other side. And then you cancel. And Ma is by itself, and that's what we want. Why? Because that's what we're going to solve for this. So it will be, so 2.5 times 10.0 divided by 15.0 equals 1.67. And that will be your molarity, okay? Molarity of your acid. Okay. Now on your test, I think most of them were moved like similar questions, but it was just the numbers were changed. Okay. And then of course we have 32. What will happen to the pH of a substance if the concentration of hydrogen ions increases from 1 times 10 to the negative 5 power, and then molarity to 1 times 10 to the negative 11 power molarity? Keep in mind that the exponents are the pH values. Okay, the pH will change from 5 to 11. That's all it means. That's what's all it's happening. The pH is changing 5 to 11. Okay, and the exponents are the pH values. Okay. The next one, what is the pH if the hydrogen ion concentration is 1 times 10 to the negative 9? That is a pH of 9. Remember that the exponent is the pH. Okay. Number 34, determine the hydrogen ions and hydroxide ions concentrations that have the following pH value of 12. So for hydrogen, well, that's easy because this is pH meaning H plus ions. So H plus ions, all you have to do is do the same thing as here, 1 times 10, but you use the negative 12 as your exponent. And the OH, all you have to do is 14. Again, there's another typo here. So it's 14 minus 12 equals 2. Okay, so on this one, all you have to, the 2 is the exponent, which is right here. Okay, so sorry about the typo. Oops. Okay, but anyways, that is your answer for that one. Okay, well, I hope you typed it up or you could use a video to help you out to answer your questions. The minimum I ask is that you type it through as much as you can, and then I give you 100 or, on the, at least on the review. Okay? Okay, good luck, you guys. Wish you the best.